Greetings, YouTube. Beautiful Mind here. We have this question from College Algebra 2. It says the height of an arrow shot from a bow is modeled by this function, where x represents the number of seconds since the arrow was shot, and f of x represents the height of the arrow in feet. There's a few questions. Part A, will the arrow ever reach a height of 10 feet? Explain your reasoning. B, what is the maximum height reached by the arrow, and at what time does it occur? C, what does the y-intercept represent in the context of this problem? And D, at what time does the arrow reach the ground? Okay. So for part A, it says, will the arrow ever reach a height of 10 feet? Well, this equation gives us the height of the arrow based on the time. So we're just going to let the height, we're going to set the height equal to 10 and then solve for x. All right. So let's see. So for part A, and let's shrink that down just a little bit. Okay. So we said we're going to set the height equal to 10 feet. So we have this negative 16x squared plus 21x plus 4 equals 10. Okay. So we're going to set it to 0. So we'll subtract 10 from both sides. Negative 16x squared plus 21x. 4 minus 10 is what? Negative 6 equal to 0. Do we have any greatest common factors? Right, we're trying to factor this guy. That's what? 4 times 4, so 2, 7, and 3, and 2. Okay. Okay. So a couple of ways that we can go about factoring this guy. We could use the quadratic formula. I'll just make a quick note. Quadratic formula. X equals, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks. And it was all over by 2 a.m., right? That's the quadratic. So, you know, your A would be negative 16, B would be 21, and C would be a negative 6. And you can use that to solve for X. I'm tempted to try to factor. If I was going to factor this guy, I'll use the AC method of factoring. So my A times my C, let me see, 60 plus 36 is 96. So I would be looking for two numbers that multiply to give me 96 and add to give me 21. Okay. Now for 96, Malachite, thank you. We said what, 60 and 36. So 6 times 16. So 16 is 4 times 4, so that's a 2 times 2 times 2 times 2. And 6 is 2 times 3, right? So again, I'm showcasing the AC method in factoring. I'm going to go through all the factors of 96 and stop at the line that adds up to 21. I'm not seeing anything though. 2 and 3. Because 21 is what? 7. 21 is 7 and 3. So none of these combinations will get us there. Okay. So instead of trying to factor this guy, because I kind of just thought about it, I'm just going to, let's try the quadratic formula to solve this. Okay, so let's do this color. So if we let our A be negative 16, let our B be 21, and let our C be a negative 6, okay? So then X is going to equal negative 21 plus or minus the square root of 21 squared minus 4 times our A times our C. Okay, all over 2a. Okay, let's keep going. Okay, plus or minus. Hey Google, what's 21 squared?
21 squared is 441.
441, okay. That's going to be a negative result. Hey Google, what's 4 times 16 times 6?
That would be 384.
All over a negative 32. Let me see. 41 plus 16, 41, 51, 57. $57 is irrational, right? Divisible by 3. 27 is a 9. So 3, is that 3 and 13? $19? Yeah, and that's still not gonna, because it's a 30 and a 27. Yeah, 3 and 19, it's not gonna go any further. So then we can divide both of those. What is that at? 8 and a 4, I think. So we can just we got a double negative that we can get rid of. So ultimately we get that this is an exact result, 21 plus or minus the square root of 57 over 32. Let me clean this up. Again, plus or minus. And then, we will use a calculator to get approximations there. Let me see. Will the arrow ever reach a height of 10 feet? Let me see what these numbers are. So if I pull up my calculator, reload and refresh. Okay. So then 21, let's do it like this. 21 minus the square root of 57 divided by 32. So what's the x? Number of seconds. So 4/10 of a second. And then the same thing, but instead of a minus, we want a plus. That seems pretty quick. Okay. I guess it could be the case. So the results that we're getting is that after 4/10 of a second and almost 9/10 of a second, it's going to be at a height of 10 feet. So it's like a parabola or a U-shaped curve. So it seems like it will pretty quickly, like instantly, be at 10 feet and then coming down pretty quick at 10 feet. So it says, will the arrow ever reach a height of 10 feet? We will say yes. We would say something like, yes, when x is approximately 0.42 seconds. And it's like 0.89 seconds. Which it could be like a little bit more horizontal, like it's trying to hit a target or something. Instead of long range, it's just trying to kind of go straight. So we got a result like this for part A. Okay. And again, we ended up having to use the quadratic formula because we couldn't get it to factor, and that's just how it kind of turned out. We subtracted 10, negative 6. Yeah, we tried to factor it, but we couldn't find none of the factors would give us a middle term, so we defaulted to the quadratic formula and we got a result. For part B, what is the maximum height reached by the arrow, and at what time does this occur? So notice that the original, the highest degree is a power of 2. So take a moment. This is a good time to pause after this question. If the highest power on any variable is 2, what's the general shape? What shape should it take? So pause for a moment. Okay, and we're back, and hopefully you got an answer. It should be a parabola, a U-shaped curve. Because the leading coefficient is negative, which way does the parabola open? Does it open upward or does it open downward? This is a good time to pause. Okay, and we're back. And so because the leading coefficient is negative, our U-shaped curve is going to open downward. So if we have a U-shaped curve that opens downward, that means we're going to have a maximum value. So for parabolas, and that's going to occur at the vertex of the parabola, right? So for parabolas, we have a formula to take us directly to the vertex, the x-coordinate of the vertex. That's like our h from our h comma k, which is the x-coordinate of our vertex. That's going to be, it should be negative b over 2a. Okay. So from the quadratic formula, we can use those results. That should be a negative 21 over 2 times negative 16. Okay. Double negative is positive. 20, 32, right? So then we have 21 over 32, 7 and 3. I guess that does not reduce down. Let's do 21 over 32. So the max height should occur when x is when our h value is like a 0. We'll say 66, and we'll say approximately, because we're rounding. Okay. And then to find the corresponding height, we plug this into the original. So I'm going to get a copy of the original, and I'm going to put it here. My y equals, I'm working on a TI-83 plus. We got a negative 16x squared plus 21x plus 4. Okay. We want to evaluate this. Let me see if I can pull it up. Yeah. At that value of x. So maximum height, 10.89, approximately 10.89. Let me see. So the arrow reaches maximum height of approximately 10.89 feet. 10.89 feet after you can say approximately 0.66 seconds. Okay. Okay, so again, I usually try to put my formulas in green, so just as a, what does the y-intercept represent in the context of the problem? So the y-intercept is that if we let x be 0, so with that being 4, we're saying that the arrow was shot from a height of 4 feet. So C, a y-intercept of 4 feet. Let's back that up. So the y-intercept suggests that the arrow was shot from a height of 4 feet. device is struggling a little bit today. Okay, let's see part D. At what time does the arrow reach the ground, right? So if the arrow's on the ground, that means our height, right? Our height is going to be what? A height of 0. So we want to take a copy of the original, and actually, we want a copy of the original, and we want to set the height equal to 0. Okay, so let's see if we solve that one. Let me see if I can do my factoring this time. I don't think so, because we still, let me see. Those are all 2s. Yeah, we're not going to get anything that adds up to 21 if everything is all 2s. So let's use the quadratic formula again. Let me see. So then x equals, and again, we can use the quadratic formula because we're dealing with a quadratic equation. The highest power is a 2. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks. It was all over by 2 a.m. That's a student of mine in the past showed that to me. That's how he remembers the quadratic formula. And so I know it's a little bit not PC, but it could be adjusted. But that's called, that technique what you just saw me use is called the memory palace. Like whenever you're trying to remember something, hey, can you have a seat? Sit down. My dog is like pacing around the room. It's making me so anxious. Sit down. Lay down. Thank you. But yeah, when you have, lay down. Lay down. Come on, lay down. She's just going in circles, and I'm like, why am I getting anxious? Because she's just going in circles. Okay, but yeah, when you have something that you're trying to remember, you can associate each component with, like, basically you want to associate it with like a zany image, story or image. The zanier the image, the easier it is to remember. So for me, the quadratic form is like a little movie, and that's how I remember it. But you can. That's called the memory palace technique, okay? So, let's see. Here, our A is -16, our B is 21, and our C is 4, okay? So, let's plug these in. Did you down me again? Darn. I got to charge my pen. Give me just a moment. Yeah, like with this pen, when I first got it, they were like, well, a 10 or 15 second charge should keep it charged to like 30 minutes. So I'm just stalling right now to try to give it at least that amount of time. We're about to wrap up this question, and then we'll move on to the next one. Okay, should be able to write. Okay. All right, so if we're going to plug these in, negative b, so -21 plus or minus the square root of b squared, minus 4, our a is this, and our c is this, all over 2a. Okay. I think I am just going to use my calculator. Let me see something. 16 squared. Hey Google, what's 21 squared plus 16 squared?
The total is 697.
697. Mm, 15. 22. Okay, I'll just use a calculator here. So we do have a double negative. We can really just get rid of those negatives. The top is going to be 21 minus the square root of 697. And then the bottom is just 32. Okay, so when we use the minus, we get a negative result. I think that's out of context, so we'll probably get rid of that one. Because if we're talking about time, we're going to let time start at 0, so the negative result we have to discard. Let's go 169. Again, we're going to scrap this result. And we need to redo that, but instead of a minus, we need to do a plus. 1.48 seconds. Okay. At what time does the arrow reach the ground? So that's when the arrow has a height of 0. And we got, that occurs after 1.48 seconds. Okay. So I'll be sure to send you a copy of this PDF, this document. Yeah. So with that, we're going to end the session here. And from one beautiful mind to another, take care and peace. All right. So greetings, YouTube. Let's see. We have Beautiful Mind here. We have this question that comes from College Algebra 2. This is our example 4 from this text or this document. It says a t-shirt is launched from a launcher with an initial velocity of 5 meters per second. The height of the t-shirt is modeled by this function, where h represents the height in meters and t represents the time in seconds. Draw the graph of the function. Okay. What is the maximum height reached by the t-shirt? At what time does the t-shirt reach the ground? And then what does the y-intercept represent in the context of this problem? So I'm not sure if you're allowed to use like graphing calculators or not. If you're not, one thing that you can do is maybe make a table. So choose several values of t and then find the corresponding y and plot the points. Yeah, and then like a free graphing utility would be something like, I know sometimes the students, if they need to like, you do like a digital graph, there's a site called desmos.com or algebra.com. Both of those sites allow for free graphing utility. There's a little bit of a learning curve here. Give me just a moment. I was stalling trying to give my pen a chance to charge again from the last one. Okay. So free graphing utilities. One is called desmos.com. Another is called algebra.com. Okay. And that's for like creating free digital graphs. I'm going to use my TI-83 Plus. If I weren't allowed to use a graphing utility, I would make a table of values. So choose several values of t, find the corresponding h, plot the points, and connect them with a smooth curve. Again, notice that the highest power in any variables are 2. So we would anticipate a U-shaped graph. The leading coefficient is negative, so a U-shaped graph that opens downward that has a y-intercept of 1.5. Right? We could also use that vertex formula to find the vertex of this guy. So then, find a few points, things of that nature. I'm just going to do my graphing utility. Okay. But again, we're expecting a U-shaped graph because the highest powers are 2, that opens downward because the leading coefficient is negative, that has a y-intercept of 1.5. Now, for the graph, what your teacher might want, they might want you to be a little bit more detailed than I'm about to do right now. I'm just going to kind of show the shape But you know, they're gonna want like the tick marks on the or the x-axis and the y-axis, and everything labeled properly. So if you need to see that, just let me know, and we'll come back and do that. Okay, so let's go to our y equals. We're going to do a negative 4.9 x squared plus 5x plus 1.5. Okay. I'm going to just do the standard window for right now. It may or may not show. So we need a better window. It looks like our x values go from like -1 to like 2. Our y values, what is that, a 1 to go up to about 3. So I'm going to change the window. My x minimum, we can go -1, that should be okay. X max, let's go to 2, should be okay. The scale on the x-axis, I'm going to go by 0.5. So each tick mark is going to be 0.5. Y minimum, I'll just go down some, maybe like down to -3. Y max, I think we needed to go to about 3. I'll go to about 5. Let's go to 5. Y scale, we can make each tick mark on the y-axis 0.5 as well. Okay, so now we should get a better window. Okay. And so I'll submit this. So you saw how we kind of constructed it to get the proper window. Again, if I need to go through more details on this graph, just let me know and I will. I'll just take like this. Okay, so draw the graph. What is the maximum height? Let's work B here. So again, for a quadratic, notice we have a U-shaped curve that opens downward. We said we had a y-intercept of 1.5. And I think on the y-axis, we went by 0.5, so that's why it's the third tick mark. So the x-coordinate of the vertex, which is our h, that's going to be -b over 2a. So from the original function, our b is 5. Our a is a -4.9. Okay. So then we just need to calculate that. This will give us the x-coordinate of the vertex. Then we take our answer and plug it into the original to find the corresponding y. Okay, so it looks like we have a double negative. It's going to be positive 2 times 4.9. Should be slightly more than 1. No, never mind. So the vertex is usually listed as h comma k. So again, the x-coordinate of a vertex is approximately, we'll just do 51. Let's see the units. After that many seconds. Okay. So then the height, which is our k, I'll just call it k for now, is basically going to be h of 0.51. Okay, so we need a copy of the original. I'll put it here, my y equals. Is this, am I doing the same question again? No. Hang on. Anywho. Okay. So then we have that in there. So we want to evaluate that function when x is that 0.5. Okay. We get a height of approximately 2.78. I think the units are feet. meters. So the units are meters, 2.78 meters. So again, this is rounded. Okay. At what time does the shirt reach the ground? So if it's going to be on the ground, again, what do? Pause. This is a good time to pause so you can think for a moment. Okay, and we're back, right? So when is it? If it's going to be on the ground, that means the height is going to be 0, right? So for C, we need to set it equal to 0. (4.9t squared plus 5t plus 1.5. We want to set it to 0 and solve. Something like this, probably just the quadratic formula is the easy way to go because we got all these decimals. Negative b plus or minus the square root, and I'm not really writing out a form. I'm doing this. So negative b plus or minus the square root of b squared minus 4 times our a times our c all over 2a. Okay. It's positive. Okay. So here, I'm going to do my negative 5 minus the square root 5 squared minus 4 times negative 4.9 times 1.5. I'm going to close off my square root. I think I need another parentheses right here because insert like that. Because we want to say the whole denominator, not just the square root, but the whole denominator divided by 2 times a negative 4.9. Okay. So we might get a negative result here. We got a result. It's not negative. Okay. So then we got t is approximately 1.26 seconds. It should be seconds. Or, so when we did the minus, we got 1.26 seconds. Or, I feel like we should have gotten a negative there. Let me check. Negative 5 minus the square root of 5 squared minus 4 times that divided by 2 times negative 4.9. Let's check the other one. Let's just check the other one. I might be jumping the gun a bit. So same thing, but instead of this being a minus, this needs to be a plus. Oh, Oh, okay. So the discriminant might be, is the discriminant 0? It can't be. Or a perfect square? No, it should be 0. Am I missing a negative? Something seems off. Let me check this discriminant. So that's going to be a 5 squared minus 4 times a negative 4.9 times 1.5. It's behaving like it's 0. 54.4. Why are we getting... Oh, because I didn't change it to a plus. Yeah, that's why we're getting the same result. Right here. That needs to be a plus. I thought I did, but I guess I didn't. Okay. Okay, and there's the negative. I was like, one of these guys should be negative. Okay, so yeah. So we got it. So, or negative 0. We'll say 24 seconds, right? And again, in the context, a negative doesn't make sense in the context, so we will scrap that result and just go with the above result. Okay. So for C, at what time does the shirt reach the ground? After approximately 1.26 seconds, right? Okay. And then what does a y-intercept represent? The starting position of where the shirt was launched from at a height of 1.5 meters. So then D, the y-intercept, can't write today. The y-intercept represents the starting position of the shirt being launched at 1.5 meters. Okay, let me see here. I am going to shrink this down just to get it on one page. Is that where that was at? Okay. All right. And so with that, we'll end the session here. From one beautiful mind to another. Take care and peace. All right. Greetings, YouTube. Beautiful mind here. And we have this question from College Algebra 2. Let's see. It says, I know it's a little blurry. A t-shirt manufacturing company's profit is modeled by this function where x represents the number of t-shirts sold and f of x represents the profit in dollars. A few questions. 1, can the company's profit ever reach 90,000? Explain your reasoning. 2, what is the maximum profit the company can earn and how many t-shirts must be sold to achieve this profit? And then 3, sketch the graph of the quadratic function and label the key features, the vertex, intercepts, and axis of symmetry. Okay. So can the company's profit ever reach 90,000? Give me just a moment. Ooh. Okay. So let's get a copy of the original. So we have, we have this f of x equals 0.05 x squared. It looks like a 125x minus 3600. And for the first question, if this function models the profit and we want to know if the profit can ever be 90,000, then we'll just set this guy equal to 90,000. X squared, 125x minus 3600. We want to set it equal to 90,000. Okay. So subtract 90,000 from both sides to set it to 0 and solve. $93,600. Okay. Again, something like this, it looks like we should use the quadratic formula to solve. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So then negative 125 plus or minus the square root of 125 squared minus 4. A is negative 0.05. And our C, I'm going to have to resize this. Is that negative 93,600 2 times negative 0.05. Okay. Let me resize this real quick. Okay. Okay. So I'm just going to use my calculator. Okay, and I'm going to do my minus first. So my numerator, I have this negative 125 minus the square root 125 squared minus 4 times negative 0.05 times this negative 93,600. Okay, this should close off the square root. This should close off the numerator. That does take practice. The challenge, the way I'm doing it is keeping track of your parentheses and getting those right. So that, that just takes practice. 0.05. Okay, double close. Okay. So we said, oh, not real answer. So it looks like that. I think whether it's a plus or a minus because the discriminant is negative. So then that backs us up, right? So then it says, can the company's profit ever reach 90,000? We would say no because the discriminant is negative, right? So if we said 125 squared minus 4 times a negative 0.05 times a negative 93,600, we should get a negative result there, right? Because the discriminant is negative, we can't take the square root of a negative, so no solution. So, let me see. The profit will never reach 90,000 based on this model because we have a negative discriminant. Let me see something. I think it's spelled this way. Siri, spell discriminant.
Discriminate.
No, not
D-I-S.
not discriminate. I think it's an E. Siri, spell discriminant as in the quadratic formula.
Here's an answer from byjuice.com.
Okay. Okay, I guess we're good. Yeah. Okay. So that's that one. So will it reach that? We would say no, because we have a negative discriminant. Let's try that again. Okay. So then the second question, what is the maximum profit and how many t-shirts must be sold? So again, the highest power is power 2. So we have a U-shaped curve that opens downward. It opens downward because the leading coefficient is negative. So that means we're going to have a maximum value. And that's going to occur at the vertex of this parabola. And so we can use our vertex formula. The vertex is usually h comma k. So the h is our x corner of the vertex. That's going to be a negative b over 2a. So then here, negative 125 over 2 times the negative 0.05. So double negative is positive. 125 divided by 2 times 0.05. Okay, so if we produce and sell 1250, what is this, shirts? Yeah, 1250, right? Okay. So then that tells us when the max occurs. To find the actual max, we got to plug this into the original. So we need to find f of 1250. Okay. So let me go here to my y equals, and I'll just type it here. So we have this negative 0.05 x squared plus 125x minus 3600. We want to evaluate that function when x is, I think we got 1250. So max profit of 74,525. Which confirms what we got in the previous part, because we said, will it ever reach 90,000? We say no. So let's do like this. The company will reach a max profit of 74,525 when they produce and sell 1250 shirts. Okay. Then the third question. Sketch the graph of the quadratic function and label the key features, the vertex, intercepts, and the axis of symmetry. So the axis of symmetry is the x corner of the vertex. So the vertex, we actually just found it here. I'll do it in green. Go ahead and label it as part 3. So the vertex is our h comma k. And in this case, it ended up being the 1250 shirts, and the corresponding y was the 74,525. Okay. The axis of symmetry That's going to be the x coordinate of the vertex. It's 1250 shirts. So using that, and we have the vertex, we have the axis of symmetry. You can use that to create the graph, right? So if you plot the vertex, and then, whenever you choose a point on the left side of the axis of symmetry, you automatically get a point on the right, right? So you can just choose several values of x on the left. It'll automatically match up with values of x on the right. They're going to have the same y value. And then you connect them with the smooth curve. And I'm just going to use your intercepts, y-intercept, you said x is 0 solve. X-intercept, you said y to 0 solve. We're going to need a better window. Let me see our x value. If that's a 1250. What's the y-intercept? Negative 36. Okay, so for the x minimum, let's just go like a negative. Let's go negative 500. The max on the x-axis, let's go like 3,000. The scale, let's go by 250. The y minimum, let's go down to like negative 5,000. The max, we got like 74,000. Let's go up to like 90,000. The scale, let's go by 5,000 on the, let's go by 2,500. Yeah, 2,500 on the y-axis. Okay, let's see if that, trying to get a good window. So we got a good window. Let's change our y-axis a little bit more. 90. If we went by 9,000, there would be 10. Okay, let's go by 9,000. Okay. And so then just be sure to include your labels. You got your vertex, axis of symmetry. Again, for your intercepts, for the y-intercept, you let x be 0 solve. For the x-intercept, you let y be 0. Did we do that already? Yeah. No, not there. No, I don't see it. But I'm going to use this graph. But keep in mind our window and the scale that we did. So there's still more work that needs to be done. I'm just doing this for the sake of time. Again, if I need to go into more details on the graph, just let me know. Again, I'm just using my digital graph, but you saw how we created a window so we could see it. I think those were all the parts. Vertex, intercepts, and axis of symmetry. Okay. All right. And so with that, we're going to end the session here. And from one beautiful mind to another, take care and peace. All right. Greetings, YouTube. Beautiful Mind here. And we're back with another question from College Algebra 2. It says, a firefighter holds a horse 3.5 feet above the ground and sprays water towards a window that is 32 feet, a hose, towards a window that is 32 feet above the ground. The path of the water can be modeled by this function, where V of t represents the vertical height of the water in feet, and x represents the horizontal distance from the firefighter in feet. Can the firefighter stand at a distance from the buildings under the water reaches the window? Using the discriminant, okay. What is the maximum height reached by the water, and at what horizontal distance does this occur? Let me see. 3.5 feet above the ground, okay. Sprays the water that is 32 feet above the ground, okay. So the path can be modeled by that. Okay, 32 feet. Okay. So the height, the path of the water is given by this formula. We want to see, can it reach 32 feet? So let's start off by setting this height equal to 32 feet. Okay, so for part A, we have this negative 0.02 x squared 1.05 x plus 3.5. We want to set it equal to 32 feet. Okay. So to solve this, we're going to set it to 0. Subtract the 32 from both sides. Let's see, is it still here? Okay. So we'll say 3.5 minus 32, negative 28.5. Seems like the quadratic formula would be simplest here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Another of my mentors would say every time you use a formula, write it down. That constant repetition of writing the formula ingrains it in your memory. So usually you'll see me write it. So if we plug in b here, it's going to be a negative 1.05. B squared is 1.05 squared. Our A is a negative 0.02, and our C, negative 28.5, almost out of space. And our 2A, negative 0.02. I'm just going to put it in the calculator like that. Now another technique, I'm using a TI 83 plus. You can so for instance, I want let me see. So we got this negative 0.02. I want to store that as alpha A. Okay. And then we got this 1.05. I want to store that as alpha B. And then we got this negative 28.5. I want to store that as alpha C. Okay. So now we've basically labeled our A, B, and C, and then we can just basically just type in the quadratic formula. So we can do, let's do like this, parentheses, negative B, let's do minus square root B squared minus 4 times A times C, close the square root. Let me see, it's probably going to be minus 4, it's going to be negative. It's probably going to be no, because it looks like we're going to have a negative discriminant divided by 2a. And let's put this in parentheses. But yeah, I think we're going to get an error. Looks like we have a negative discriminant. Just quit. Okay. So then, can the firefighter stand at a distance from the building so that the water reaches the window? It looks like it's a no. We're going to say no, comma, because we have a negative discriminant. All right. So it's trying to produce a non-real solution. We can't take the square root of a negative. Okay. What's the maximum height reached by the water? Okay, so max height. So for B, we can use, again, so highest power on any variable is a 2, like as in here, right? So we would anticipate a U-shaped curve. It's going to open downward because the leading coefficient is negative, right? So we have a U-shaped curve that opens downward, something like this, then that means we're going to have a maximum value, okay? So that's going to occur for a quadratic at the vertex. So the x-coordinate of the vertex, which is our h, is going to be a negative b over 2a. So in this instance, it's going to be a negative 1.05 over 2 times a negative 0.02. Double negative is positive. I'm going to just clear these out for now. 1.05 divided by 2 times 0.02. So 26.25. Is that feet? Yeah, feet. Okay, so the max is going to occur when the water's 26.25 feet away from the firefighter. And then we need to plug this back into the original. So again, the vertex, we usually label it as h comma k. The x-coordinate of the vertex, which is our h, can be modeled by negative b over 2a. And then the k, we take that result and plug it back into the original. So our k is going to be f of that negative b over 2a, whatever the answer we just found. So we're going to do f of 26.25. Okay. So we need a copy of the original. Okay, I'm going to clear this out. Negative 0.02x squared plus 1.05x plus 3.5. Okay. And we want to evaluate this. Let me see if I can pull that number back up. Okay. So we want to evaluate this function at that answer. 26.25. Max height. We're getting approximately 17.28. Should be in feet. Were those all the parts? So the max height was that at a distance of this 26.25 feet. So this is the max height. At a distance of 26.25 feet. Okay. And so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, take care and peace. All right, greetings YouTube, beautiful mind here. We got a couple of questions from College Algebra 2. This number one on the left, it says the line graph shows the percent of cars for sale at a used car lot on a given day by model year. For what model year is the percent of the cars for the sale the smallest? It looks like, what's that, 2014? So that one looks pretty good. So yeah, 2014, I can agree with that. And then it's question number 2. It says, the graph of a system of linear equations is shown. What's the solution to the system? So we got these two graphs, right? We got this guy and this guy. So the solution to the system is going to be here at the point where they cross. The x value there is a 4, and the y value is a -5, so the A looks good. Okay. So yeah, I'd agree with these. And so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, take care and peace. All right, greetings YouTube, Beautiful Mind here. And we have these series of questions that come out of College Algebra 2. It says, tell the type of sample each situation represents. You're interested in finding out if students at your school think that fine arts programs are receiving enough funding. You decide to either 1, use a written survey that you give to people sitting at your lunch table. That's considered a convenience sample or a volunteer convenience sample. And basically, you're just using whoever's easiest to access at your own table, right? So that's a convenience sample. Let's do this in purple. Okay. Put a table at the entrance to the cafeteria with a sign directing students to complete the survey if they want, and drop it in the box. Voluntary response sample. And so my recommendation would be to just cross-reference these with your text. Like text that I've worked with, you know, we basically had these similar concepts that may have been worded a little different. Sorry. So, you know, just cross-reference these with, like, in your text, there should be a list of types of samples, and you just kind of comb through and just, you know, match them up based on this. Okay. Randomly selected students from each of the 4 grades is a stratified random sample. So the 4 grades, a random sample taken from each one. Let me see. So this one was considered a census. It could also be a convenience sample. I'll put that in parentheses. I don't know why I still know this. That seems random. A simple random sample. Every name has an equal chance of being drawn. All right, so so a simple random sample. Every name has an equal chance of being drawn. And then this is an observational study. Dr. Jones wants to see whether the gender of members in a tribe in the Amazon plays a role in the order in which is this an observational study or an experiment? This is an observational study because he's just watching or observing. I'm just going to highlight it right here. Dr. Jones also wants to see whether the monkeys in the area grew up larger when eating their native diet or when given manufactured monkey pellets. Is this an experiment or observational study? What are the treatment groups, control group, and treatment? Sounds like an experiment. So this is an experiment. The treatment group. So the monkeys given the pellets, manufactured pellets. control group are the monkeys given the native diet. And the treatment is that the researcher is manipulating the diets of the monkeys. Let's see. Draw a normal curve for, let's see. Draw a normal curve for a normal distribution with an average of 30, okay? A standard deviation of, that's cut off. And it might be something other than 5. Okay, I'm gonna have to assume that that's a 5 because the image is cut off. So a standard deviation of 5. Label all areas under the curve. One standard deviation, okay. So, so our mu or average is the 30, it's in the middle, and then each tick mark is, the standard deviation is 5. I wonder if it needs the percentages. So let's do some colors here. So when we're plus or minus, so when we're a plus or minus 1 standard deviation from the average, that's approximately 68%. Of the population. And then when we're plus or minus 2 standard deviations, that's about, so 68 goes from here to here, and then plus or minus 2 standard deviations is about 95%, and that runs from here to here. Let me color code this a little bit. What's my time? Okay. So plus or minus 2 standard deviations, that's going to take up about 95% of the population from here to here. And then plus or minus 3 standard deviation is about 99. So from here to here is about 99.7% of the population from there to there is under the curve. Okay. Okay, give the percent of the area under the curve represented by the shaded regions. Okay. So again, here's our average, and then plus or minus 1 standard deviation will be from here to here. Now normally that would be 68, but it looks like we only have half of it. So 70 would be 35, so 34%. So this guy should be 34% right there. Okay. And then, so 2 standard deviations from here to here will be 95%, right? So then, let me see, 90 will be 45, 46, 47.5. So then half, so it looks like we need about a quarter. I don't know if that's necessarily a quarter. Okay. So if from here to here is 95, right, we can cut it in half. Half of 95 is 47.5, but then we got to remove the 34% from the 47. So then hopefully that's making sense, all right? 47.5 minus 34% to give us, so then that shaded region should be 13.5%. It's this guy. Okay, so then when we are 3 standard deviations away from here to here, that takes up 99.7. So since the shaded region is on the outside, that's going to be part of the 0.3, right? 3/10. But then it should be half, right? Because 1/2 is on the left, the other half is on the right. So then 0.15%. Should be this region here. Where's this? 9. I don't think I got that one, so. Okay. So I'm going to go with those results. Okay. Oh, so then we probably need to add those up, right? Because it probably wants a total percentage. So if we add those together, I'll just do it here. 34 plus 13.5 plus 0.15, 47.65. Okay, yeah. So the total shaded region, I would say there is 47.65%. Okay. Oh, please stop doing that. Come on. All right. Man, we're getting a lot of work done. Okay. And then this last one, I'm just watching the clock. My alarm goes off in like 3 minutes. So I'm trying to finish before that happens. Okay. I want to say we can use results that we got from before, right? So it should still be like, this should be 34% here, as well as this one should also be 34%. And this one should be 0.15%, right? 68.15, unless there's something cut off. So if we add those together, it should be 68.15%. Similar argument to what we had just a moment ago. Okay, let's see. We got one more. 100 students out of 1,200 at a school were surveyed. 14 said that they had a school drive. Predict the number of students in the population that would answer similarly. 100 students out of 14 out of 100. Okay. So of the 100 they surveyed, so the percentage there, so 14 divided by 100 is 14%. And then if the school population is 1,200, so as a decimal that would be 0.14 times the population of 1,200. So we would anticipate 168 students to answer similarly. Okay, come on. Okay. All right. So again, I'll be sending you a copy of this document once I'm done with everything. All right. And with that, we're going to end the session here. And from one beautiful mind to another, take care and peace. As an average of this and a standard deviation of 3, draw a normal curve that represents this. Okay. So greetings, YouTube. Beautiful mind here. We have it says Algebra 2. We usually have these in problem stats and some other courses, but this is fine. A normal distribution has an average of 42 and a standard deviation of 3. Draw a normal curve that represents this. Okay, so something right like this. So our average, so we'll have something about like that. Our average is 42 here. And then about there's 1 standard deviation, about 2 standard deviations, and 3 standard deviations, okay? So 3, so this will be 45, 48, 51, 39, 36, 33. Okay, and then when what percent of the values between, okay. So again, we said what, 68% is 1 standard deviation away. So basically from here to here. So this one, 95%, 2 standard deviations away from here to here. And then we'll do this one, 99.7%. That's not clear. Let's choose a different color. 90, was it 99 or 97? Yeah, 99. So 99.7% is 3 standard deviations away. Okay. So what percentage of the values lie between 33 and 45? So if that's 50 plus, well, maybe let's not say 50. Let's calculate those. So if we're 1 standard deviation away, if that's 68, 35, so 34%, right? So we get 34% here, right? I think it just helps if you just calculate each of those little sections. So 95, let's see, 45, 46, 47.5 minus the 34. I know we just did this. So 47.5 minus 34, 13.5% is here. 99.7. So let's see, 99.7 divided by 2 is this, minus 34 minus 13.5. So that's 2.35%. It's here, okay. So then if we want from 33 to 45, we say the 2.35 plus the 13.5 plus the 34 plus an additional 34. Okay. So 2.35 plus 13.5 plus 34 plus 34, 83.85%. Hopefully that's not too small. Please stop. Okay. So we got 83.85% there. Running short on time. Okay. What percent lies above 48? Okay. I need that region over there. So if that's 99.7, right? So then there's 0.3, so 0.15. So this little region over here is 0.15%. Okay. So the amount above 48, we would say the 2.35 plus the 0.15. So 2.5%. Okay. Below 35. Oh, did we do this right? Minus 3 is a 39, 36. I don't know if that's a typo or not. Like if they meant to put a 36 there instead of 35. This one might be a little off. It's slightly less than 2.5%, but that one I'm a little not sure. Again, I'm kind of short on time. This one, I'll put a star next to it. Let me check something. Let me see. Okay. I feel like that one might be a little off. 48 above. It should be that. I would think it would be both of those that are together. I'm going to go with my answer. Oh, 35, 33, 34, 35, a third. Okay, so if that's 68%, that's 95%. So if that's 2.35%, can we cut that into a third and then 2/3? So if we do let me see something. So between that 33 and 36, right, if we cut that into thirds, I'm just playing around, 2.35 divided by 3, and then we'll say times 2, is that about 1%? Below the 35. Plus 0.15. I'm getting this. I'm not confident in this answer for C. I don't know, these are a little bit off, so, you know. Yeah, I would just put a star. I would inquire about those. Again, I'm kind of short on time. 1.72%. Because, like, I'm not sure. Oh no, hang on. Undo. Did I lose my work? Okay, I think we're good. Because I'm not sure if that's a typo, if they meant to put 36 or not. That's actually good. All right. Let me see. Got a good amount. Let's see. So the high temperatures for the days in January are normally distributed with a standard deviation of 5 degrees, average of 38. So then this will be a 38. And then we add 5 and subtract 5. So let me see, if we did 10, 38, that would be 48. 5, 2 and 3, 43. This would be a 53. 38, this would be a 28. I think this is a 33 and a 23. Okay. What is the probability that the high temperature for the day will be at most 46? So that's about halfway. Okay, I'm going to have to pause right here. All right, so we are back. I had to go to work and get back. So, you know, we were generating our numbers using just using the chart, you know, based on the standard deviation and the average and getting approximations. So then I was like, well, I know that there's like a z-score and another chart that you can use. So I was kind of playing around with that, and I kind of confirmed the results that I got a little bit. For instance, so like if we're going to use like a z-score, and we have to use like a chart. So for instance, we have this formula, like our z-score. Oh, shoot, are you dead? Oh, my pen, it just stays dead. Hang on. Now this thing was charging all morning. All right, so give me a moment to just let my pen charge for a bit. So, you know, again, in this example, like I was kind of playing around with example 12, right? So our average, or our mu, is the 42. Our standard deviation is 3. Okay, I'm gonna try to use my pen. It should have enough for me to write a little bit. Okay. So like the z-score. Oh, why are you not working? Okay, let me do this. I'll be right back. so hopefully this doesn't disturb the microphone. I think I had to just, nope, that didn't work either. Why is it not working? Ugh. Okay, that works. Okay, now it's working for whatever reason. Oh, the app crashed. Okay, so it was the app and not my pen. Because I was like, yeah, I charged this pen like, it should be charged. So I think the pen is charged. I think the app was just crashing. Okay, let's try to get back to where we left off. Okay, so let me see the z-score. What is it? It's x minus mu over our standard deviation. So like x is our test value, I think it is. Mu is our average, and sigma on the bottom, that's our standard deviation, right? So like for instance, and then there are these like phi charts or phi charts, but you know there's a specific one that we have to recall or use because we're going to use the left end tail, because they kind of different charts focus on different things. Let me pull it up. So for instance, this is the one that I was kind of playing around with, the negative z-score table. We want to estimate the area under the normal distribution to the left, but this is a negative z-score. I don't really want to use, not that one, not that one. I think this one. I think that's the one. Let me kind of check. Yeah, to the left of a positive z-score, right? So I'll come back to this. We're gonna use this one for a positive z-score. Okay. So if we want the percentage between 33 and 45, right? Let's calculate the z-score for the 45, right? So if we say x minus mu over theta, I'll clear this out. So that's going to be 45 minus 42 divided by the standard deviation of 3. We get a positive z-score of 1. So now when I go to this chart for positive z-scores, it's giving us the left hand, the area under the curve to the left of our z-score. And I know it's small, you won't be able to see it, so I'll read it off. But a z-score of 1 has a value of 0.84134, right? So let me see. I'll just put it here. Again, the z-score associated with 45 got a result of 0.84. I think it was 84134. So what it's saying is that 84.134% of the data is to the left of 45, right? So then we do something similar for the 33. All right, so we want to find the corresponding z-score for 33. And so like earlier we used the normal distribution, and that gives us an approximation. Let's do the same thing for 33. So I think this one will give us a negative z-score, so we got to use the other chart. Okay, so now we're going to do 33 minus 42 divided by 3. And we get a z-score of negative 3. So then that's where this other chart comes into play. Not that one, this one. And this should be in the back of your textbook. So these are z-scores associated with, these are the outcomes associated with a negative z-score. So we got negative 3. So on this chart, it's a 0.00135. Right. So 0.135% of the data is to the left of this z-score. So if we want the percentage between, we would say the 0.84 minus the 0.00. All right. So then we would basically subtract these results. 0.84134 minus 0.00135, and we get about 84%, which is approximately what we have, right? 83. So in orange, we got 83.999%. Okay, but that's, again, these are all approximations. So using the normal distribution chart, again, this chart should be in the back of your text. One for a positive z-score, one for a negative z-score, and the results in this chart are telling us the percentage of the data in these cases to the left of our z-score. Okay, and we have the formula on how to find the z-score there in green. So then let's try this for part B, for question 12. If we want the area above 48, all right, so we can still use the same chart, find the z-score. The chart is going to tell us the percentage of the data that's less than 48. So then we will say 1 minus the result to get the amount above 48, right? So let's start off by finding the corresponding z-score. So then we will say 48 minus 42, all divided by 3. We get a positive 2. So then we want to go back to our z-score, our chart for positive z-scores right here. We got a z-score of 2. Let me check it one more time. Yeah. We got a z-score of 2. And that's a 97,725. So again, this was like A. This is B. $97,725. So that means that 97% of the data is below 48, but we want the amount above. So what we're going to do is say 1 minus that result. So then, so this is going to be 1 minus 0.97725 and 2.275%. That's close to what we have. Again, approximations, right? So when we use the chart here, we got 2.275% above 48. All right, so taking an estimate using our normal distribution curve, we got the purple. And then when we start incorporating like z-scores and things of that nature, we're getting these results in orange. All right, so I'm going to highlight this one there. This result is there. What percent lies below 35? Okay, so let's find the corresponding z-score. We're going to say 35 minus 42, all divided by 3, standard deviation of 3. We get a negative 2.3 bar, so we're going to go to our negative z-score. .3 bar, negative 2.33. 2, 3. Okay. 00990. Double O 990. So we're saying about 0.9% is below 35. And again, the result we got in purple was an approximation, because I think 35 was not a multiple of the standard deviation. So that's why it was like, you know, so then I thought about it and I remembered this technique in orange. So hopefully you can kind of track that. Okay, so I'm probably going to be using that going forward. Let's see if that works for 13. I'm not saying these answers are correct. I'm just saying I know that this is another technique and it's close to what we had before. So in many other cases. So the high temperature for days are normally distributed with an average of 38 and a standard deviation of 5. What's the probability that the high temperature for a day will be at most 46? Okay, so let's try the same thing for part A. I'll do this in, let's choose another color. We'll do burgundy. Okay, let me think. I think I'm doing this right. Probability the temperature will be at most 46. Okay. Yeah, I want to say these charts are giving us the probabilities. So let's find the corresponding z-score. So we're going to say our 46 minus our mu, which is 38, divided by our standard deviation of what, 5? Okay, so with that z-score, we get a z-score of 1.6. So we got to go back to the positive one, which is this one. Z-score of 1.6, 9452. 9452. Mm-hmm. Mm-hmm. So there's a, let me see. Mm-hmm. Okay, yeah, so we got a probability of 9452. Again, we said the 46 minus 38 divided by 5 gave us a z-score of 1.6, and then reading the chart at 1.6, we get the 9452. Okay, so I'm just going to go with that for now. Let me think. 46. And notice that the 46 is like over here. If that's 50, 84 plus about half of that. 84 plus 7 is about 90. Yeah. So I'm just, again, I'm just using the z-scores. Again, that green, okay. The green formula that you see on top. And then the charts that you see me switching to. Oh, shoot. Okay. What's the probability the high temperature will be at least, so to be greater than 36, okay? So again, for greater than 36, first we're going to find a z-score like normal. So then we're going to have this 36 minus 38 divided by 5. So it gets a z-score of a negative 0.4. Then we go to our negative z-score chart. And this negative z-score chart of negative 0.4 is telling us the percent of the data to the left, right? But we want the amount to the right. So negative 0.4 has a probability of 34.458. So that's going to be a 1 minus 34.458%. Okay. One minus 34.458. And I guess in this way I'm writing it, I need to put 100 or move my decimal. Okay. So we're getting approximately 65.542%. Okay. What's the probability the high temperature will be between 32 and 44? So in these cases, when it's asking for between, you just calculate each one like normal and then subtract your answers at the end. So then for the 44, we're going to say 44 minus 38 divided by 5. We get a z-score of 1.2. So then the 1.2 has a probability 88.493. So we're going to say the 88.493% minus. So then the other data point is the 32. So we're going to say find the corresponding z-score. 32 minus 38 divided by 5 has a z-score of a negative 1.2. So then if we go to our negative z-score chart, which is here, negative 1.2, 11.507. So 11.507%. So then if we want the probability that's between, we subtract these two numbers from each other. Okay, clear. 88.493 minus 11.507, 76.986. Okay, so yeah, let's just kind of keep going. Okay, the average age of reading the worlds is 18. Okay, so this is 18 with a standard deviation of 1. So that means this is 19, 20, 21, 17, 16, and 15. Okay. How many people, it has a population of 10,000. How many people would have read the book between ages of 17 and 19? Okay, so if we do the same thing, we find the probability and then take that probability and multiply by a population of 10,000. I'm sure there's a faster way, but let's just do the same thing, right? So 19, let's find the corresponding z-score. We're going to say 19 minus 18 divided by 1. That's fine. We get a z-score of 1. So if we go back to our positive z-score, uh, 84,134. So then 84.134% minus, I think we're going to get -1 for that other one, but let's just confirm. So all we do is the same thing, but replace 19 with 17. We do get -1, and then on the negative z-score chart, -1 is 15,866. Okay, so between 17 and 19, we're going to subtract those two results. Okay, 84.134 minus 15.866. We get this result. Okay, let me make a note. 68.268%. Then we're going to take that and say times 10,000. Because the population is 10,000. So move the decimal to the right by what, 4 spaces? 1, 2, 3, and tack on a 0. Oh, actually, okay, I'm gonna have to, I'm gonna try to finish this one out, then I gotta charge my device. As a percent, we need to write that as a decimal since I'm short on space. Instead of point, the decimal just needs to move here. Come on. Oh no, come on. Right here. So now when we move the decimal, now when we multiply by 10,000, 1, 2, 3, 4. Let's see, 1, 2, 3, 4, about 27, 68, 26.8 people. So about 68, 27 people. Again, the device is about to die, so I'm going to try to wrap this one up. How many people would have read the book between the ages of 16 to 20? Okay, so let's just do the same thing. With the 20, let's see if I can, let's just do this. So with the 20, we'll say 20 minus 18. Actually, you know what? We can use the standard deviations, all right? Because between 17 and 19 should be 68%, right? Of the population, which is about what we got, right? 68%. Between 16 and 20, that's plus or minus 2 standard deviations. So from the 68, 95, 99.7 rule, that should be 95% of the population. So it should be like a 0.95 times 10,000. Let's see, 95, 1, 2, 3, 4, about 9,500 people. All right. So when you're working with the standard deviation, there's the whole 68, 95, 99.7 rule. 68% of the data is between plus or minus 1 standard deviation. 95% of the data is within 2 standard deviations of the average. And 99.7% of the data is between plus or minus 3 standard deviations of the average. How many people have read the book between the ages of 15 and 21? So that's the plus or minus 3. So 99.7 times the 10,000. So 997, 1, 2, 3, 4 people. We got that result. We got this result. And you can honestly simplify that first one to, you can also put, it's essentially 6,800 people using the 68, 95, 99.7 rule. Okay. My device is about to die, so I'm gonna charge it, and we'll be back momentarily to kind of finish out the remainder questions. All right. And so with that, we'll end the session here. And from one beautiful mind to another, take care and peace. All right, greetings YouTube, beautiful mind here, and we are back. I guess these are coming from like a college algebra 2 honors from high school. Where I come from, this is more problem stat. We don't have this in our college algebra, but it's fine. So I think we're getting to the bottom of some of these. So let me see. This one says a normal distribution of scores has a standard deviation of 10. Find the z-scores corresponding to each of these. Okay. All right. So with this one, my battery is really low, so I'm not able to use my microphone right now. In the interest of time, that's why I'm going ahead and making this video. So hopefully you can hear me okay. It shouldn't be as clear as when I have my microphone in, but you know, you should be able to hear me okay. All right. So in the previous example, we came across the z-score formula, all right? X minus mu over our standard deviation, or over sigma. Okay, so in this example, use this color, it pops a little bit better. Standard deviation. Let me see, it has a standard deviation of 10, 20 points above the average. It didn't. Okay, so question number 1, I'm not seeing, unless, I don't want to assume that the average is 50. Yeah. It didn't give us the average on our mu, but we can just fill in what we have and kind of proceed accordingly. So I just call this, I don't know, but this z-score. So then if it's 20 points above the average, then that would be, x would be what? Mu plus 20, right? And then we would say minus our mu. I'm just plugging this into the formula over, and a standard deviation of 10. So it looks like a z-score of 2, right? Because the mu's would cancel, we would have 20 over 10 to give us a z-score of 2. Let me shrink that guy down. So the first one keeps doing this. Okay. A z-score that is 10 points below the average, okay? So that z-score is going to be mu minus 10 minus mu over 10 to give us a result. Again, these guys will cancel. We get a result of -1 there. I think I'm going to make my pen a little bit smaller. And I'm going to shrink this down to size. Okay. A score that is 15 points above the average. So that z-score would be mu plus 15 and then minus mu over 10 to give us a z-score of 1.5. $30 points below the average. So mu minus 30 plus mu divided by 10 gives us a z-score of -3. And, you know, they weren't asking for any probabilities here. They were just asking for the z-scores. Okay. Probably should have started here. That may have made it a little bit easier. All right, so let me see. The Wiltshire Adult Intelligence Test Scale is composed of a number of students. On one subtest, the raw scores have an average of 35 and a standard deviation of 6. Assuming these raw scores form a normal distribution, what number represents the 65th percentile? What number separates the lower 65% of the distribution? Let me see. 65th percentile. Okay. Let me check something. I mean, I think we're pretty much doing the same thing with the z-scores, but I just want to be sure. So let's go like this, actually. I'll get rid of that right here. This one. This one. And it should just be the z-score. That's fine. Okay. Oh, okay, so the lower 65. Okay, yeah. So let's find the corresponding z-score. Let's just see what happens, right? So for part A, so if we said what 65 minus the average, which is 35, and the standard deviation is 6. Minus 35 divided by 6. Let me see. And then let's look at our chart. So we got a z-score of 5, positive 5, which is going to be this chart up here. I think that goes off. Let me check it again. I mean, 65th percentile. Let me think about this. Lower 65 below this value is the z-score. Let me check the chart. 65%. Okay, from this chart, 65 is right there between 0.08, so 38. Z-score is 0.385. Okay, approximately 0.385, okay. Let me see. So that didn't work. Let me get rid of this real quick. Delete. What number? 65th percentile. Average of 35. Okay, so that's the z-score. Okay. Okay. So let me kind of just crunch this real quick, and then I'll give an explanation. So I'm getting a z-score of approximately 0.385, right? Now if we use the z-score formula, x minus mu over sigma. So then if we put this together, we're going to get, I'll do this color, x minus, now the average is 35 over 6 equals 0.385. So then, okay, now it's coming together. Come on. So then we get a score of, what is that, a 35 plus 6 times 0.385? 37.3? Okay. Okay. So what number represents the 65th percentile? We're getting approximately 37.3 a score. So then here, a score 37.3. Come on. My device is struggling. That's my percentage. Okay, it's still growing, so that's going in the right direction. Okay, so let me explain how I got this result. So if we want this, we want the 65th percentile. So we want our x value needs to be greater than 65% of the rest of the data. So then I just started on this the standard normal distribution chart. And so the results in the chart give us the percentages, right? So if we want 65%, kind of towards the top, that 1, 2, 3, that fourth row from the top on the far right, between almost halfway between the 8 and the 9 is where the 65% lies. And if that's the fourth row, so then that's where the 0.385 came from. I have to call her back. Hang on. Hey, I got you on speaker. I'm doing a recording. Were you still trying to go to that movie?
No, I couldn't. I can go. What time? Yeah, what time you want? You want to go? What time is it?
Let's do another day. I'm doing a recording right now. Is everything okay? This is being recorded. Am I recording?
Oh, okay. Well, never mind.
Yeah.
I was gonna get you to get some information for me, but that's all right.
Okay.
All right.
See ya. Okay. So yeah. So for this one, if we wanted a 65th percentile, I looked in the chart, and it's the fourth row in the between the last two. It's about halfway between the 0.8 and the 0.9, and so that was 0.385, right? So we got a z-score of 0.385. That's where this guy came from here. Okay. So then if I wanted the corresponding score, I use this formula. I plugged in my z-score and worked backwards, right? So here's my z-score. Here's the formula. The average was 35. The standard deviation was 6. Multiply both sides by 6 and add 35. That's what is 37.4. So my claim is that when somebody scores like a 37.3, they're going to be in the 65th percentile, right? Okay, so what? Let's try for the 90th percentile. Okay, so if we want them to be greater than 90%, so from this chart, we have to scan. I see a 90 there, right? So the 90 looks like it appears between a 0.8 and a 0.9. 90 in the third row. So 1.285. So the 90th percentile, we're getting a z-score. I'll just put it here. We're getting a z. Oh, did you die? Are you crashing? Let me reboot this. There's too much going on. I can get rid of this as well. Get rid of that. Get rid of that. Hopefully, are you working now? No. Okay, you're still booting. That's what we need. Now they did get something slightly different. So again, from this chart, 1.2, I'm getting approximately 1.2, so 90. One point two 1.285, give or take. So I'm getting a z-score of approximately 1.285. So we found a percentile. It was between 2. So it's between the 1.28 and 1.29. There's a little bit more to do to make that more precise, but this will get us close. So if we're getting this z-score and we want to find the score corresponding to that, we got to work backwards like we did in the other one. So we would say x minus 35 over 6 equals 1.285. And then solve for x from there. So then 35 plus 6 times 1.285. 42.71. Yeah, that's good. So here we're getting a score for approximately 42.7. Let me see. What's the probability of a score between 28 and 38? So now they gave us the score, and we can kind of work forward. The part A and B, we were working backwards, starting with the percentages and working backwards. So now we can start with our scores and work forward, right? So the 38, right? The corresponding z-score there, we would say 38 minus the average, 38 minus 35 divided by 6. We get this z-score. And the other one is 28. I'm going to just go ahead and crunch that one too. 28 minus 35 divided by 6. Okay, so we get 0.5 and we get a negative 1.16 bar. Okay, so we need 2 charts. So let's get the percentage from the positive 0.5. So we need the positive z-score chart. Is this the positive z-score? Yeah, 0.5. Okay. 69,146. So we get this 69,146 minus. Now we got this negative one, so we need to go to the negative z-score chart, which is this one, negative 1.16 bar, negative 1.1. Let me see, that's a 0, 1, 2, 3, 4, 5, 6. So about halfway. It is a little bit 0.12, 300 and 100, 300 and 100. So we might be able to get away with 0.122, 200. 0.122. Let me look at it again. We got 6 bar. Negative 1.1, 0, 1, 2, 3, 4, 5, 6. All right, I'll go with 0.12200. Basically like this. Okay. So this is an approximation. It's not going to be the way I'm doing it. You know, it's not 100% there, but we're pretty close. Like it should be pretty much there. Okay, so probability. So then I'm going to do 69.146 minus 12.2. So about a 56. So I'm getting a probability of about 56.946%. For that one. Yeah. Okay. And then what's the probability of getting a score between, it looks like a 41 and 44. Let me change the size of this. Okay, so same deal. All right, let's do the 44 first. Okay. So we get a z-score of 1.5, and then the other one is a 41. So a positive 1.5 and a positive 1. So let's go to the positive z-score chart. Now the 1.5 has a probability of 93,319. And then the z-score of 1, 84.134. So if we subtract those two, $93.319 minus 84.134, 9.185. So about a 9% chance to get between those two. Okay. Let me see. Scores on the SAT from a normal distribution with an average of 500 and a standard deviation of 100. What is the minimum score necessary to be in the top 15%? So if you're in the top 15%, that means that, 85% is below you? So if we go to the chart and look at, and basically work backwards, right? 85%. So we're looking at the results, right here. So we have to kind of track. I see an 85 right there. So it goes from 84 to 85. Okay, I'm just going to go with the 0.04. So 1.04. It might be a little bit less than that, but we're going to z-score of 1.04. Okay, and again, we want, again, if we use the z-score formula, x minus mu over our standard deviation, so we can kind of work backwards to solve for our x. So again, we're solving for x. Our average is 500. Our standard deviation is 100. 1.04. Let me check that one more time. Right there. 1.04. Okay. So then if we solve for x from there, 100. So that's a 104. 604. It looks like x is approximately a 604 score. Those three. Yeah. Okay. Let me see. Find a range of values that defines the middle 80% of the scores. Middle 80. Okay, so there's what? So 10 off the top and 10 off the bottom, 90%. So if we want the middle 80, 90 and between 10% and 90%. Okay. So we want to find the scores associated with like that's between 90% to 10%. Okay. That leaves 10% on either side for the 80. So the 90% from the chart, that z-score, I think we found it earlier, but is right there in the middle. I think that's like 85. 1.285. So the z-scores. What's the z-score associated with the 10%? So now the 10%, we might need to go to the negative z-score chart. Right here. And 10%, let's go down here. Okay. All right, so one of these guys. Okay, right there. So we'll say about halfway. 2.5. So looks like it's a 2.325, a negative 2.325 z-score. Okay, so then times 100 plus 500. One, is that a 3 or an 8? I think it's an 8. So with this guy, the score associated times 100 plus 500, 628.5. This one times 100 plus 500. Okay, I'm going to do this. Come on. So we're going to say 500 minus 232.5. 267.5. Okay, so we're saying that the range of values that define the middle 80% should go from 267.5 through 628.5. So those scores. Let me see. B. They got 372 to 628. 10%. Let me check that 10% again. 1.28. Am I looking at something wrong? 10th percentile. 1.28. Let me check that 10% percentile again. So I'm getting a negative z-score there. %. Oh, you know what? I may have done, if it's 10%, it needs to be 0.1, and I may have done 0.01, right? That might be the trouble there. So if I check my 10% again, right there, 8.5. Okay, so we'll do, 0.85. And that corresponds to 1.285. Okay, yeah, I definitely did the wrong thing. So right here, negative 1.285. Okay. I was reading the chart wrong. Negative 1.285. Okay, let's fix this. I'm just going to change this, and I'll do the change in burgundy. Okay, so times 100 plus 500. So it's going to be 500 minus, come on, 128.5. So 128.5. Okay. 371.5 or 372 is fine. We got a 371.5, and that's pretty much the same thing. So scores between these values fall in the 80%, right? So again, when I read the chart, I think I was looking at 0.01 instead of 0.1. We wanted the 10th percent, so I was reading the percentage wrong. So basically, we were working backwards. We were given the percentage, and we wanted to find the corresponding score. In the other examples, we were given the score, we wanted to find the corresponding percentage. Okay. For a normal distribution, find the z-score that separates the distribution as follows. The highest 30% from the rest. So the highest 30% means your z-score is at 70. So from the chart, if we're at 70, it's probably going to be in our positive because we're above 50. So this positive z-score chart at 70, okay, it looks like it's going to be about 0.5 something. 70 is right there. So 70, okay, so 0.525. So here I'm getting a z-score 525. Let me see. Yeah, that's good. Okay. separate the lower 40%. So we want a 40%. So I think we're going to have to go down to our negative chart, negative z-score chart. 40%, so that's like a 0.4. Okay. Right there. Okay. So 40 is about halfway, 55. Negative 2.55. So the corresponding z-score is approximately a negative 2.55. Am I reading that right? That's not right. 40, 0.255. Fix that. 0.255. Okay, B. Yeah, that's fine. That's pretty much the same thing. So it's okay, that's fine. The highest 75, which means that you're above 25%. So we need to go to the chart to 25%. So the same negative z-score chart, 25%. Let me see. Right there. And it's on the money. No, it's not. 25%. I'm still reading it wrong. Let's go a little higher. Okay, 25. Right there. We can go about halfway. So 25. So 75. Right there. Negative 0.675. Okay. That's basically, they're giving us this. They're giving us the percentages, and we have to work backwards to find the corresponding z-score using one of those normal distribution charts. 675. Okay, yeah, that looks pretty good. Okay. So again, hopefully you can hear me okay. I know we got interrupted a little bit. But a lot of this, and again, if we need to be live and talk about this, we can. A lot of this is coming out of those charts that you see me using, and using that green formula. The green formula tells you how to find the corresponding z-score when given your test value x, based on mu or average and sigma or standard deviation. But these examples, some of them are giving us our x value and having us find the probabilities, and some of us are given the probabilities and having us work backwards. Right? Yeah, so with that, we're going to end the session here, and I think we've got a couple of more pages, so we'll be back momentarily to do the remaining sections. With that, we'll end the session here. From one beautiful mind to another, take care and peace. All right, greetings YouTube, beautiful mind here. We have these questions from Honors Algebra 2, so this is more stats. I think in our algebra we don't have stats, but it's fine. I do stats a little bit. So this question, I know it's a little blurry, so we'll do the best that we can. The average on the test in my class and Mrs. Merrill's class were normally distributed on the last advanced algebra test we gave. The average in my class was 86 with a standard deviation of 3. The average on Mrs. Merrill's test was 82 with a standard deviation of 4. If you made 88 on my test and your friend made 85 on Merrill's test, who had the better score in comparison to the rest of their class? Okay. Your z-score. Okay. So if we're doing the z-scores, right? So far, what we've been doing thus far, when it comes to z-scores, the z-score was x minus mu over the standard deviation. Okay. Now, if you made an 88 on my test, right? So then the z-score there, it would be 88. Now, let me see. Average in my class was 86, and a standard deviation of 3. So the z-score 2/3. So we'll say 0.66 bar. But then your friend, so that z-score, they made an 85, and the average there was an 82 with a standard deviation of 4.75. Let's look at the percentages, all right, corresponding to those z-scores. So these are both positive z-scores, so we're going to go to our positive z-score chart. 0.66. So that one puts you in the like the 74.5 percentile. I'm just going to put the percentile here. 74.5th percentile. And then 0.75, I think it's a little bit better. 1, 2, 3, 4, 0. 1, 2, 3, 4, 5. 77.337 percentile. So then the friend, it looks like the friend did better. If we did these calculations properly. Okay. Given these test scores in my class, draw a box and whisker graph for the data. Okay, let me look that up real quick. Box and whiskers, so it's like you have, I think it's the quartiles, like the first quartile, third quartile, your average is in the middle, and then your outliers are on the end. I think that's how that goes. But let me do this real quick. Right here, we are working, I think it's this one. Come on. Okay. Okay. So one thing that would help here, if we put the data in its ascending order. All right, let's do that. So it looks like the data sorted would be what? 50, 78, 80, 81, 87, 89, 2 90s, 99, and a 106. 2, 4, 6, 8, 10 data points. So if this is in this order, like Q2, let me see, it should be what? 5 and 6? 1, 2, 3, 4, 5, and 6. The average of those two, we'll put it at 88 for Q2. So let me think. So halfway, 1, 2, 3, 4, 5 would be between those two. Halfway would be the 80 for Q1. Now why are they getting 0.25? 90. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let me see. 1, 2, 3, 4, 5. So then halfway would be the 90. And that one should be 80. Okay, let me check one other thing real quick before I speak on this one. Just gotta refresh my memory. Box. Let's see, box and whisker. Okay, I just want to see something real quick. Just need the image. Maximum. Okay, right. So if we're going to do box and whisker, let's do like this, right? And this is our interquartile range. Let's go like this. I don't know how to get it to not snap to a grid. I'll do something like this for the time being. Or I know something else I can do. Let's do something like nope. Okay, so we'll work with this. Hopefully this way is a little bit better. All right. Oh, don't do that. Okay. So like, I want to say like here we have outliers, like we have our max value. Like here we're going to put our maximum. Ooh. Again, here we're going to put our max. Come on. All right, let's try this one more time. There we go. Our max value there, our minimum value here. The IQ interquartile range should be going from what is that? Q2 to Q4, Q1 to Q3. Let me see. So the 25% for Q1, right? We have 10 data points, right? 1, 2, 3, 4, 5, and then another 1, 2, 3, 4, 5. So there's that, and then halfway between those is the 80, right? So I would imagine this would be like 80, but that's going to give me something else, but this is fine. And then the right here, 1, 2, 3, 4, 5. Halfway on the upper portion is right here, which is the 90. Okay. The maximum value that we're getting is 106. And the minimum value we're getting is 50. We'll just move this over here because we're out of space. Let me make sure I got everything. And the median. Let me see. Convert data to box and whisker plot. Okay. I just want to see a finished example. I think. This might be okay. And then maybe identify our median, duplicate. Never mind, delete. Let me see. 1, 2, 3, 4, 5. That should be 88 there. Let's see. Let's see something. Mm-hmm. 78 outliers. Let's consider. Wait a minute. Am I missing something? Okay, we got that one. Lower fence, Q1 minus 1.5 times the interquartile range. Come on. 78. 80 to 90. Okay. Yeah. Are they treating it like an outlier? There might be a little bit more because I'm seeing things about like outliers and something about the. I feel like I'm not doing something right or it's just scaling left whisker, right whisker, outliers plotted beyond the whiskers. Because like it just depends on some specifics. Like if there might be a little bit more about like outliers and like there's 1.5 times the interquartile range. I'm going to put a star next to that one. Interquartile range and like also for Q2. But they might be getting something different because they're considering outliers like the 50 and the 106 to be outliers, and or. So based on what I have here, let's see. So it says the interquartile range is Q3 minus Q1, so that would be. Yeah, we're getting about 10. Again, there might be. I feel like this is a little bit adjusted. I feel like this is close, but not all the way there. Are there any outliers? So it is asking for outliers. Okay, let me do this. So 1.5 times the interquartile rule, Turkey method. This is method high school algebra. Sort the data, okay. Find Q2 with 10 values, an even number. The median is the average of 56. We got that. Q1, lower half. So the median of these is 80. I got that, yep. Some textbook interpolate to get 8.25, but many use the simple method. Here it's just 80, yeah. And then that should be 90, yeah. Calculate the interquartile range, 10, we got that. Cutoff points for the outliers, lower fence, okay. So for the lower fence, it's going to be Q1 minus 1.5 times the interquartile range. Okay. So, okay, let's write that. So the lower fence should be Q1 minus 1.5 times the inner quartile range, right? So that should be 80 minus 1.5 times 10. So 15, 80, 70, 65. Okay, I think we're... So, with that being the case, I'm going to just move this. This, it looks like this, come on. This should be like a 65 right there. And then, you know, we got an outlier of the 50. Ugh. Come on. Nope. Undo. There we go. And if we do something similar for the upper fence, right? So we'll say the upper fence should be Q3 plus, I would imagine, yeah, plus 1.5 times their interquartile range. So in this instance, that would be what, the 90 plus 1.5 times 10. 15 is the 105. And this one was 65. So we got this as an outlier. This here is 105. This is an outlier. Let me see. This is a little bit different, but that's fine. Any value below the lower fence or above the upper fence is an outlier. So the 50 and the 106 are outliers. Okay. So are there any outliers? Show your work. We have this work. So 50 and 106 are outliers. So we'll do it here. Let's see, so 50 and 106 are outliers. Okay, if you take the 50 and the 106 out of the list, are there any outliers with either calculations? So the 50 and the 106, come on. Did I lose my work? Oh no. How do I get that back? Right here. Ooh, okay. So if we remove the 50 and the 106 out of the list, are there any outliers? So we probably have to recalculate everything. So now we have, what, 8 squares? So let's just redo it. So if we remove 50 and 106, keeps jumping. 50 and 106, I'll just get a copy here, right there. Copy and paste. Yeah, that definitely changed, and it wasn't supposed to. Okay. So we remove the 50 and the 106, and we basically want to redo the box and whisker. Oh. Yeah, it's kind of acting up because I'm drawing on a picture. So we got 8 values, 1, 2, 3, 4, 5, 6, 7, 8. So then if we were to redo the box and whisker, I'll just do it here. Let's do it like this. I want to duplicate that. Okay. Okay, that's gonna do for now. Let me see. So this one. 1, 2, 3, 4. So this is the halfway mark, right? So our middle is still 88. So now that we have an even number on the bottom hand side, that means our Q1 is going to be what, 80, 80.5? This would be 80, 80.5. And then 1, 2, 3, 4. And you still get a 90 at the top. 90. Let's see. So then for the lower fence, Q1 minus 1.5. The interquartile range in this case is 9.5. I need a calculator. Q1 lower fence. So we're going to take that 80.5 minus 1.5 times 9.5. 66.25. And then we want to redo that. But now we're going to take Q3, which is 90, plus 1.5 times 9.5. 104.25. Do we have any outliers now? Anything? I don't think we have anything less than 66, nor anything. So if we remove the 50 and 60, are there any outliers with either calculation? We can say no. No outliers. That's good. Okay. So what's the margin of error when you survey? What is the margin of error when you survey 8674 people? So there's a couple of formulas at play. Probably want to go through the rough formula. 1 over the root n. Plus or minus? Should it be plus or minus? Yeah. Okay. You have to check this formula to make sure that it's correct. We're going to use plus or minus 1 over the square root of n. Okay. So I'll just abbreviate it as like margin of error. We'll say plus or minus 1 over the square root of the 8674. Again, all of these are with a star, so you just gotta, this is just like me looking at it and a little bit of cross-referencing. 1 over the square root, 8674, 0, or we'll say plus or minus 0.0107. Let me see. Yeah. Oh, let me make sure. 0107. So roughly 1%, that's fine. Okay, so margin of error, right? If we use the same formula, there is another formula, but for our purposes, for right now, we're just going to use the one that we've been using. Let me get rid of this word. So, please, okay, good. Okay. So for our margin of error here, 1 over the square root of, you surveyed this many people, 81% saying yes. Square root of 923. Let's just go with it. 923. Okay, so we get an approximation. One over the square root 923. So about 3.3%. Okay. So then we can do like 81 minus 3.3. So we're getting a range of 77.7% to 84. 84.3%. Okay. Okay, how many people did you survey? Okay, margin of error. Okay. So we've been calculating the margin of error. We've been doing 1 over the square root of n. I want to say normally it's plus or minus, but looks like we're going to square both sides and that'll get rid of the plus or minus. This equals, okay, so we got this. This is fine. Plus or minus 3.2%. Okay, let's see. If we square both sides, right, we'll have 1 over n. Let me think. Is this okay? 3.2 squared. 10.24. flip both sides. That can't be right. Margin of error. 3.2. Probably need to change it to a decimal. Yeah, that's what we're missing. Okay, right here. So 3.2% as a decimal, 0.032. Now when we square both sides, 0.032 squared. Okay. 1024. So then when we flip both sides, so we're going to say 1 divided by that answer. So about 976 to 977 people. We'll say about 977 people. Okay. Oh. My battery is steadily getting stronger. We were all the way down to 1. Then we were at 3 or 4. Now we're at 7. So I'm not using. So that means I can't use my microphone. I feel pretty good about these results. If we need to go into further detail or look deeper into any of these, just let me know. But we're going to go ahead and stop in the session here. And I think we got a couple of more pages left for the whole shebang. All right, so with that, we'll end the session here. From one beautiful mind to another. Take care and peace. We'll be right back in just a moment. All right, greetings YouTube. Beautiful mind here. Let me see. So we have these questions from Algebra 2. If the variable is not in the blank, then it is blank and exponential function. If the variable is not in the exponent, then it is not an exponential function. A is not 0. The base is a positive number other than 1. If the variable is not in the either power or exponent, then it is not an exponential function. This looks like the leading coefficient. Siri, spell coefficient.
Coefficient.
Got it right.
C-O-E-F.
Thank you. I want to say this is the base. Okay, identify the following functions are exponential if they are. State the initial value and the growth or decay factor. If they're not, explain why. We would say yes. Our A is a 1 and our base is a 2. That looks good. I would say yes there. It's a decay factor. No, sorry. Exponential, we would say no. Because the x is not in the power, right? So this is that exponential, we would say no. Because x is not in the power. Okay, exponential, I would say yes. Our leading coefficient, initial value is -3. Base is 2.6. Exponential, we would say yes. Initial value is 10. Our B is like, we do 1/6. So that's a decay factor of 6. I would say no. There's no variable x in the power. Okay. Do they just want examples? So a linear function like 2x. So then something like this. Exponential function, something like this. Let's do e to the x. If blank, if blank, then the graph will grow away from the asymptote as you move left to the right. Exponential growth functions, if it's like if the base, if b is larger than 1, then the graph will grow. I think that's what it is. If this is larger than 1, then the graph will grow away from the asymptote from the left to the right. If it's between 0 and 1, it's going to decay. The x-axis is an asymptote. With a graph, an asymptote is an imaginary line that a graph approaches more and more. Okay. An asymptote is an imaginary line that a graph approaches more and more over time. As x goes to infinity. In this case, honestly, this is x approaches negative infinity in this instance. So they want us to do an example. I'm not really sure what they want us to do here. Okay, but with these conditions where the base is larger than 1, exponential function, exponential growth would be like this. You have your asymptote. That's your y equals 0. The domain of this guy is all reals. So the very left to the very right. The range is the very bottom to the very top. It gets really close to 0 and it goes up to positive infinity. Infinity always gets a 0. A parentheses. And in this context, because we get infinitesimally close to 0 but we don't reach it, it gets a parentheses. Okay. I think we have one more example, one more question, so we'll be back momentarily to work on that one. Again, just if anything isn't clear, just reach out to me and we can try to clear up, because I know some of these are a little bit dicey. But just let me know. Sorry, just let me know, and we can either go live or I could just try to come back and clean up some of the presentations. But with that, we'll end the session here, and from one beautiful mind to another, take care and peace. We'll be right back. All right, greetings YouTube, beautiful mind here, and this is our last installment in a series of questions. Let me see. So this is on exponential growth. Are the following graphs exponential growth functions? So when we trace it left to the right, the only one that's behaving as exponential growth Definitely the third one. Because the first one, as we trace it left to right, it's decreasing. So there's decay. The only one that's really behaving like, I would go with just this one. You might be able to argue some of the other ones, but the only one that's behaving like exponential growth is this guy. You might be able to argue the last one. But yeah, I would just, that's the only one that I know is safe. Graph this, okay. So we can choose several values of x and find the corresponding y. Okay, so let's try these values. I'm thinking, let's let x be -3, -2, -1, 0, 1, 2, and 3. Okay. Now I'm going to start with when x is 0. 2 to the power of 0 is what, 1, so we get a half there. When x is a 1, we get 1. When x is 2, 4 divided by 2 is 2. When x is 3, 8 divided by 2 is a 4, right? When x is a -1, that's 1 by 4, is that right? 1 over 2, so that's a 1 by 4. 4 times 2 is an 8, so 1 by 8. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. So y values go up to like 4. Let me see. So that's the origin. This for like a 1, 2, 3, 4, 5. 1, 2, 3. No. Yep. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative. Negative. And this is the origin. 0, 1/2. 1, 1. Over 2 up to. Over 3 up 4. What if we did 4? Let's go ahead and do 4. 16 divided by 2 is 8. Okay, so it goes off the chart at that point. And then a quarter. So these get infinitesimally close to 0 when this going in this direction. Okay. So we do have our horizontal asymptote. And actually, let's do it like this. So here, y equals 0. We can connect these with a smooth curve. So if this is our image, the domain of this guy, the very left to the very right, all reals. The range is the very bottom to the very top. So 0 to infinity. Again, we get really close to 0, but we don't reach it. So that's going to get a parentheses. For exponential functions that are of this form, the graph will go through and have an asymptote on the x-axis line y equals 0. So, for instance, when x is 0, so some key points are like when x is 0 and like when x is 1 and when x is negative 1. If we do when x is 0, then it'll be 0, comma a. When x is a 1, a times b. Okay. So graph, I guess we can do a table of values. So x versus y. Let's go, we'll go negative 3, negative 2, negative 1, 0, 1, 2, 3, maybe 4. If we start when x is 0, we get a half. X is a 1, we get 3 halves. When x is 2, 9 halves. 3, 27 over 2. So I'm not gonna do 4 because it's getting. When x is a negative 1, it's a sixth, 1 over 6. Negative 2, 9 times 2 is 1 over 18. X is 3, negative 3. 1 over 54. Right, those are basically just really close to 0. So 27 divided by 2, 13.5. 1, 2, 3, 4, 5, 6. 81 divided by 2, 6. What is that again? $13.5. So let's get 15. 6 times 3, 6 times 4, 6 times 2, 6 times 3. Let's go by 3s on the y-axis. Okay. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So I'm going to make this my 1, 2, 3. 1, 2, 3. And I think we said by 3s. So we went 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, 18. These are negative, negative, and the origin is here. Okay. So 0, 1/2 is about here. Over 1 up a half is about, like 1.5 is here. This is really tight. Over 2, 4.5. About here. Over 3, that was 13.5. That's about here. And then going in this direction, these guys are basically infinitesimally close to 0. So we get an image like this. Got your horizontal asymptote, y equals 0. Domain is all reals. The range is the open interval from 0 to infinity. So notice here in part 3 of question 3, we just have a generic exponential growth function, but we multiplied the outside by a negative. So if we use transformation of functions, it's like a y values went from positive to negative, so we should have exponential. We should have like basically an exponential growth function, but flipped upside down vertically over the x-axis, right? So let's do our x. Let's make a table x versus our y. 4. So we'll let our x be negative 4, 3, 2, 1, 0, 1, 2, 3, 4. Let's just start with 0. This seems like it's easier to kind of start there. 2 to the power of 0 is a 1, so the corresponding y there is a negative 1. When x is a 1, then we get negative 2. 2 times 2 is a 4, so that's a negative 4, negative 8, negative 16. We get a negative 1/2, negative 1/4, negative 1/8, negative 1/16. Okay. X values, y values, we go up to 16. 1, 2, 3, 4, 5, 6. I think 1, 2, 3, 4, 5, 6. We can go 3 on the y-axis, so go by 3s on the y-axis. Yeah. So if we went 3, 6, 9, 12, 15, 18, 3, 6, 9, 12, 15, 18. These can go by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These guys are negative. These are negative. And here's our origin. Okay. So 0, negative 1 is about here. Over 1 and down 2 is about here. Over 2 and down 4 is about here. 3 and down 8 is about here. 4 and negative 16 is about here. Anything else goes off the chart approximately. Negative 1, negative 1/2, and these guys basically just get infinitesimally close to 0. Like that. So we got a horizontal asymptote, y equals 0. And we can connect those with a smooth curve. Domain, all reals, so the very left to the very right. The range, the very bottom, very bottom to the very top. So it's going to go from negative infinity up to 0. We get infinitesimally close to 0, but we don't reach it. All right, so, okay. Again, so for our purposes, like, our college algebra is like, inverse functions, rational functions, and then like, actually, it's like working functions and transformation of functions. Algebra 2 would be the inverse functions, rational functions, exponential functions, log functions, and then sequences and series. So the whole question is on like the problem stats and all of that. That's a separate course for us, which is problem stat, which is fine. Again, if I need to go back over those, just let me know and I can like redo those. Because I had to kind of jog my memory. I didn't have my mind set for problem stat, and I had to like do a little bit of digging and things there. But yeah, so with that, we're going to go ahead and end the session here. Now, from one beautiful mind to another, take care, and hopefully this helps. And just let me know, again, if we need to be live or in person, or if I need to redo those, just let me know. And you might want to check them, just to check them for accuracy. You might have to cross-reference them with like your textbook to make sure, because sometimes those things the references are a little bit off. All right, and just again, if anything isn't working, just let me know. All right, take care. From one beautiful mind to another, peace.